Welcome to Part 4 on exponential functions. In many applications, the most convenient choice for a base is the irrational number e. It's also referred to as Euler's constant. It is also referred to as the natural base. It's kind of like pi, which pi is 3.14159, etc., etc. E is also an irrational number, and it's approximately 2.71828. The function f of x equals e to the x is called the natural exponential function, often referred to as just the exponential function. And you can see the graph here on the right is an increasing function with an intercept at 0, 1 along the y-axis, and also a point on the curve at 1, e. This coordinate point is approximately equal to 1, 2.7. Notice that the 2.7, though, is approximate. The graph f of x is equal to 2e to the 0.24x using the following table. Round to 2 decimal places. If we were to put 2e to the 0.24x into our calculator, which we'll do, then we can find outputs for each one of these. Otherwise, we would have to literally put this in to our calculator and calculate each one separately, which is an excessive amount of time. So in y sub 1, we'll enter 2 times second e, which is above the division sign, raised to the, and now we're going to put whatever's in parentheses as an exponent together as 0.24 times x, close parentheses. And I'll graph that. We have an exponential growth model, and now I want to see what the table is. And I can request different values as my inputs. I will substitute -3 in first. That will give me a 0.9735. I'm just going to round to 2 decimals like it will just be 0.97 as the first value. For -2, we have 1.24. For -1, we have 1.57. For 0, we have 2. And then for 1, we have 2.54. At 2, we have 3.23. And at 3, we have 4.11. So if I were to graph this, I look at my x values as the exponentials. I start at -3 and I go up to almost 1. At -2, I'm at approximately 1.24. At -1, I'm at approximately 1.5. At 0, I'm at 2. At 1, I'm at 2.54. At 2, I'm at 3.23. And at 3, I'm at 4.1, so about there. Trying to make that a nice smooth curve will give me something like this. So this curve is not a really quickly increasing exponential function, but it still represents an exponential growth function.